Hi, I'm Bob Doyle, the information philosopher, webcasting from my ITV studio in Cambridge, Massachusetts. Information philosophy is a new method of philosophizing. That is to say, a new set of tools for doing philosophy, as philosophers call it, doing philosophy. It's the first new method of philosophizing since logical positivism and analytical language philosophy appeared in the early 20th century, around Bertrand Russell and Ludwig Wittgenstein. It came to be the basic analytical method of philosophy taught throughout most English-speaking universities in the world today, although it's had a decline in recent years. Okay, so information philosophy is a systematic philosophy. That is to say, it claims to have methods applicable to all the fundamental questions about the nature of the universe, sort of metaphysical questions, and our place in the universe. Now, systematic philosophies haven't been that popular, but in many ways, information philosophy is radically different from the philosophy taught in our universities, which is the analytic philosophy, and it's radically different from systematic philosophies of the past because it bases itself not on language and clever conceptual analysis and so forth, nor on the argumentation techniques of reasoning about things, because I'm going to argue it's not possible to reason to important physical and practical truths in the universe. We can apply logic and use it to help us reason, but it isn't generative of understanding the world, which is not necessarily logical in its construction. As John Duns Scotus said, as opposed to Thomas Aquinas, Aquinas thought we could reason to the universe because the universe was created by a God. The God was rational, said Aquinas, and therefore we could reason in our ivory tower and figure out what's going on outside of the world. And John Duns Scotus, the famous predecessor of English or British empiricism, like John Locke and Hume and Berkeley, Scotus said, no, God has omnipotence. God can do anything God wants. God can create any world God wants. Therefore, you must get out of your ivory tower, and I'm kind of describing him in terms he wouldn't imagine himself thinking. We need to get out of our ivory tower, go out, take a look at the world, and see how it actually is. That's what it means to be empirical. That's what it means to be using evidence rather than theories only. We need theories. We need ideas, Platonic ideas, but we must check them against reality. We must test them. As Kant liked to say, we have to put questions to nature and ask questions about nature and see what answers nature gives back to us in the forms of poking at it and looking at it and studying it minutely today and cosmologically as well, and see what kind of a universe we have here. And then we'll know something. Scotus thought we would know something about God because he assumes it's all created by this intelligent being. I can't find any evidence for such an intelligent being, but I do find evidence for a fantastic creation process. The universe has in fact been creating itself under the laws of physics for 9 billion years, and then for the last three and a half, it's been creating us living things. We have been creating ourselves using information processing, developing algorithms by which the things going on in our bodies are managing themselves, using information processing and using flows of matter and energy coming through ourselves under the control of all of those information processing, algorithmic processes that keep us living things. And so with that introduction, I want to say that what we're going to do today, let's see if I can bring up my right screen for you. This is my blog, iFi blog, which every morning I post a new entry with a title. Here, Donald Hebb is a Canadian neuroscientist, and then a little description of what I'm going to do. And ultimately, I'll get to the end of the description and I'll add a video right here. So here's yesterday's talk on biological organisms, and are they completely determined? And with a little luck, no, I haven't added it yet. At the bottom of the screen, I will add a video. Let me just see if I refresh this page, whether I get to the bottom and find anything at biological determinant. No, I haven't done it yet. But at the bottom of epistemology, there it is. I've put a link, a video link to see the video. So I believe that this way of organizing my lectures could be useful, because going to YouTube is not necessarily that easy to find our way around. Let me discuss my operational techniques and what I'm hoping you'll find useful. Here's youtube.com. And I need to switch screens back for a moment. Here comes youtube.com, and it comes to my pages. But not exactly. I really need to go to specifically Information Philosopher. Oh, here it's kind of interesting. Here it says that we're live right now, and that could be an interesting way of doing things for me in the future. But I want to go to my channel, as it's called, Info Philosopher. And some of you may have done this, but the question I'm trying to work on is, I don't need informationphilosopher.com. I just need Information Philosopher. That should bring up my channel. Here's my channel. I have yet to decorate it with a nice heading at the top, but here's a link to our talk yesterday, another few links to the few, one day ago it says, 4 days ago, and so forth. This isn't necessarily the best way for me to present all of my lectures to you in a convenient way, but I have created a thing called playlists, which you may know about, and some of you younger thinkers may know a good deal more about putting things on YouTube and Facebook than I do, but I'm learning, and I'm interested in your suggestions of how I might do it better in the future. If I click to playlists, now you see, I'm not quite up to date, but now we have, let me bring this to full screen so you can see it better. We have playlists for free will, for philosophers and scientists, for metaphysics, for the Albert Einstein videos. First one there is on great problems, and you can just see there are 4 videos there so far that I've arranged in a playlist. Here are 27 videos from a conference in Barcelona, Spain, Catalonia, if you like, on Is Science Compatible with Free Will, which I participated in along with Al Mealy and Bob Kane and Martin Heisenberg, the son of the great Werner Heisenberg, who figures very importantly in my studies of his interaction with Albert Einstein and Einstein's views of quantum physics. So I was very pleased to meet Martin Heisenberg, and he gave a very nice endorsement to William James' thinking and my two-stage model of free will. Martin had written an article in Nature in 2009, and my very first philosophical publication on my website under publications was a little note to Nature, which they accepted, on Martin's work and how it coincided with William James' work. And Martin Heisenberg was extraordinarily happy to be associated in any way, especially in the pages of Nature, with William James. Okay, coming back, I'm describing to you whether there could be a better way of organizing my lectures. These at least have little page looks. They turn black when I go over them, but you can see the covers from my books as a guide. But now let me show you something new that I just developed yesterday. This is a page on my Information Philosopher website. So it's basically informationphilosopher.com. Again, let me enlarge it a little bit. and make it more readable for you. The link is informationphilosopher.com/lectures. And now, aha, I have not got the latest version of this page. If I hold a mouse over one of these pages, it might have the date there. See, November 20th. You may or may not be able to read that because it's kind of small. Let me push it up a little bit. Here we go. And so each lecture, if you hold the mouse open, it gives you a little date. Again, not very readable and not in that format. So what I've done is to reformat the HTML. I'm doing a lot of HTML for my website. And let's reload this, and I'll add the dates now. I've just added the dates for my first 22, and today is the 20th of December. I'll be doing my 23rd lecture. And if I keep up at this rate, we'll be doing 250 lectures in the course of this year, if my health holds up. And I hope you'll enjoy this new way of finding my lectures. Again, if we go back to YouTube for a moment, the way YouTube does it is to put them in a kind of reverse chronological order, like a blog. So I'm live now, it says, and here is a picture of me streaming against the background of my of this page. And then we see the other ones, but they're all in reverse chronological order, so you have to work your way down to the very first one. And I noticed the first one has 87 views, so things are growing. I'm getting more views of the old ones, 41, 38, than I am of the new ones, because not too many people are reading the latest ones. And go all the way up to the one we have now, and just yesterday we had 23 views. So things are going well there, but I hope you will like this look as a nicely organized look. And the titles are somewhat small mouse type, tiny little titles, but I hope you'll be able to figure out what they're about. And up here, the links I provided at the top are links to my books. So if I were to link on Great Problems, that with a little bit of luck will open another tab. Doesn't seem to have done it. Let's see, Great Problems. Click on Great Problems, and here is my book. So I've not only organized my my lectures for you, but at the top of each column, the lectures on one topic have a link which can take you into where you can find the pages of my book, okay? So you don't have to, as I've said many times, you don't have to buy the book in order to read the chapters, or here we go, let's click on Good and Evil, and up pops a copy of that chapter, and you can easily print that out or enlarge it in this case if you view it online. And here's where the story goes. Okay, I want to go back now to my my blog, which is over here. Let me switch back to SR here. And here's our topic for today. It's a scientist. Now I have to apologize because I have not yet written a web page on this very important scientist. A pioneering neuroscientist who did some of the really early thinking, not the total earliest, like the ones who drew the neuron structures, Ramon y Cajal and his colleagues, who actually saw the neurons and saw how they had long axons and growing off were dendrites connecting to other cells. So it was Cajal who told us our cortex, our brand new neocortex that fills up most of gray matter, is wired together into things we call networks today. Neural networks is a very popular part of neuroscience today. And the early workers just gave us pictures. Then some who looked at those pictures gave us ideas. And to me, the most important idea that flows into my work in information philosophy, or in information neuroscience, really, what's happening in the brain, is very simply, where is the information in our brains, which is the software and the hardware, you remember, or the immaterial aspect of our mind, which is stored somewhere, embodied in the physical material brain made up of the neurons, which are just huge cells, enormous long cells. Neurons go quite long, many centimeters long, compared to our blood cells, which are virtually invisible. Even takes a terrific microscope to see a red blood cell. But the neurons are very long, and as they head back down through our spinal column, some of them extend all the way from the back of our cranium down to our waist area and then spread out, and another meter-long neuron might go all the way to our toes or out along our arm and so forth. So neurons can be a cell which have amazing shapes. But what Donald Hebb noticed when he looked at how they're all connected, he had an idea. He, of course, was modern enough to know how the neurons work. They're a special kind of cell that can get a stimulus at one end and create an electric potential, a difference in a kind of the chemistry of the ions inside and outside the cell wall, and that creates a pulse which travels down the neuron and gets to the other end, and then it may run into something it wants to trigger. In particular, it might end its own neuron length, and then there's a little thing called a synapse, which connects two neurons together, and when the signal comes down one of them, it has to release what are called neurotransmitters, and they travel across the synapse to the next cell, and then the next cell starts firing, and the signal travels down that cell. We can't go into too much of how the neurons work, but Donald Hebb came up with a suggestion, which there are some ideas of it and traces of it in the work of one of Cahal's younger colleagues. I'm going to show you the book called Organization of Behavior, which has a lot of thoughts about our human behavior. But the important part of this work, if I can get us to 6, I guess I'm zoomed in a little too tightly for that, so let me come back here and show you this book by Donald Hebb. It's called A Neuropsychological Theory. I guess I can get a little closer. So, no, I don't want to do that. I'm going to do this, and this, and then this. And that should take you in a little closer. Very good. And I've got a tab into this book to one of the important pages in it, where we get Donald Hebb's original work, and then I'll recast it. Let me just, for the moment, go back to the title for the talk here. Hebb's claim, and this is sort of the concise way of saying what he suggested, is very simply that neurons that fire together wire together. Easy to say, rhymes nicely, but it's a very, very deep thing here. So what I'd like to see is take it back to me for just a moment. And I need to be on this screen. Sorry for all the bumbling around. What does it mean that neurons that fire together wire together? The firing is simply this active potential electrical signal. It's not electricity, it's instead a change in chemical potential across the boundary of the cell, but it travels down. So it's said to be firing every time we want to move a foot or finger. Our neurons are firing, sending active potentials down the neuron. And so what has the firing got to do with the wiring? It's going to answer our question. My question, or it may begin to answer the question, where is the information stored in the neurons? Because it's our brain which has these architectural connections which could represent little bits of information about what we know. And many people want to model it, the brain, as a computer. and the mind as a computational algorithmic processes going on in the brain, and I would agree with that to some extent. We'll see whether it's really computer-like or something else that's uniquely biological. But then we'd have the mind as the goings-on of what that brain is doing. And clearly it needs connections. Even a computer circuit is a network. Circuits can connect to memory locations. And the question that Donald Hebb starts to get into is, where is our memory? Where is our knowledge? Where is the information in my model for the mind? So where Hebb said neurons that fire together wire together, he suggested that if they are used, and a neuron would be firing in response to some experience that we have. So let's say we have a sensation of light coming into our eyes, sounds coming into our ears, the feelings coming into our skin and touch sensors, olfactory nerves firing because they detect molecules and signals being sent right up into the middle of the brain from our olfactory system. 5 senses of data coming into us, all of them are firing neurons that connect up into our brain. And so where might it be that the information is stored? What Hebb's saying is that perhaps when one neuron meets another neuron, jumping from an axon or the little body of the nucleus of the cell out to along dendrites, which 10,000 connections go from each cell to 10,000 other cells. And each of those 10,000 have connections to a different 10,000. We quickly, exponentially grow to trillions of connections in the brain. So it would seem at first blush that maybe trillions of connections are just like the trillions of bits that we have in a very large computer. A terabyte of data, maybe, or more, maybe in our heads. And to say that the signal travels from one neuron, jumps over to the other neuron at what's called a synapse, was to be thought that perhaps this synapse, when it fires across the synapse, it might remain wired. That is to say, the connection there is a lot stronger than the ones that we're born with. Just to step back a moment, when the neocortex grows in, and it takes order of 20 years to fully grow in an adult human. We have a very relatively small part of it as is in a baby, and young children, adolescents, a good deal of this growth goes on. We don't have our fully formed ability, our cognitive abilities, until we're really in the 20s somewhere, which explains a lot of our problems with our young adolescents and teenagers and so forth. But the growth of the neurons from the earliest time in this large neocortex is completely random. That is to say, the wiring is just, there's no obvious reason why anything is connected to anything else. But there's an enormous amount of connectivity. On the other hand, if a synapse is not used, is not fired, it's said to die or wither and not have strong connectivity. And it's the firing that gives them the wiring by making that synapse stronger. The term that describes these wired connected synapses is long-term potentiation. They somehow know they've been used before, and why would you want to have a synapse at a neuron connection to know it's been used before? Well, maybe it's remembering something. And that's going to be the basis of what I call my experience recorder and reproducer. And the ERR, or the experience recorder, has, in my model for the mind, the ability to replay or reproduce connections, earlier connections. And we'll see how that works in just a moment. So let's go back, start again with Donald Hebb, who is our scientist for today. And I have his 1949 book here called A Neurophysiological Theory. And I'll bring him up, I hope, on my, let's see if I go here. You'll see his book. We can take a look at this paragraph together. Careful with my switching, try to get in a little closer. And here he says, let us assume then, I'm on the neurophysiological postulate. This is his proposal. Assume then that the persistence or repetition of a reverberatory activity or trace is a very important word in the history of physiology of the brain, tends to induce lasting cellular changes that add to its stability, what's now called long-term potentiation. The assumption, and a footnote he's got on another page in the back we may look at, this assumption can be stated as follows. When an axon of cell A is near enough to excite a cell B and repeatedly or persistently takes part in firing it, some growth process or metabolic change takes place in one or both cells such that A's efficiency as one of the cells firing B is increased. Now that's a little technical, again, but today we boil that down to say that when cell A fires across its synapse to cell B, this synapse is wired, connected to cell B. And that's the initial goal of my search for where is our knowledge located in our brain, where is the information that's the basis of my information model of the mind, where is our memory in short, okay? So to tell more of the story of Donald Hebb, I'd like to point out a wonderful book to you that I strongly recommend as a great read, which has got much of the neuroscience that I'm talking about, and more, though, in the history of this man's life. This is called In Search of Memory. So here's someone's going to try to answer our question about where do we have our memory. The book is by Nobel Prize winning Eric Kandel, who is also the principal author and editor of the most important book on neuroscience. I have 2 or 3 books on neuroscience that I've been reading, and I'm now on to the 5th edition. Let me give you an idea of the weighty character of this book compared to his little memoir. This is a memoir in search of his own memory, and this is his textbook called Principles of Neuroscience, and Kandel is the leader of a group of prominent neuroscientists, and I'd like to see what they have to say about Webb and Hebb in just a moment. But let's look in Search of Memory, and we find here, let's see, I'll go down to this, let's see if I can show this a little tighter for us. And what we get here from great Eric Kandel's memoir, the idea, you see, there was an idea in the drawings by this Raphael Lorente de No, a student of Cajal, that showed the neurons connect to each other in closed pathways. So that's really important. The idea was further elaborated by the psychologist D.O. Hebb in his influential 1949 book, The Organization of Behavior, Neuropsychological Theory. And Hebb argued that reverberatory circuits are responsible for short-term memory. I'd just like to tell you a little bit of this story to entice you into considering reading this book of Kandel's. He says when he was extraordinarily young, maybe 2 or 3 years old, he was playing with a, let's see, I can't bring that up. He was playing with his, a little automobile, which was a wind-up toy, and it would drive around in circles and whatever, and he was under the dinner table with his mother and dad having dinner above, and he's looking through their legs at things going on in the room. It's 1938, I believe, when there comes an enormous banging and racket on the door. And the door opens, and what Kandel tells you, and he tells you so dramatically that you can almost visualize what he has seen 60, 70, 80 years ago, and is still visible to his eyes. He can still see this scene in his memory, and he wonders where it is inside the brain. Between the parents, the banging on the door opens, perhaps his father answers or mother answers, and in come these Nazi jackboots, and they march his mother and father away. You can see the trauma that must be involved to have burned that memory into his brain, which set this young man out to understanding how such a thing can happen, that we can vividly bring back certain very traumatic events. Particularly, you can see how someone who has had serious traumatic events repeatedly, as veterans coming home from the wars today with all their incredible explosions and death all around and so forth, you can see how some things, you may have some in your own life experience that you vividly remember exactly where you were. Many people say, do you remember where you were when when you learned that President Kennedy had been killed? I can immediately bring back the exact moment walking through a door into the library at Harvard College Observatory, my Department of Astronomy, and a couple of my graduate student friends there, and suddenly we're talking about the assassination of President Kennedy. Clearly then, it seems to me clearly, there is something going on in the storage of those events. But I need to add an extra element. What Kandel is telling us, and what Hebb is telling us, is how it gets recorded, how it gets stored, how the information is saved. But I would like to go on to speculate about how the information can play back and bring back that vision of Kandel under his parents' dinner table the last time they were taken away from him. And that requires what I call a reproducer. So let me take you back to this page. Well, I've got it right here. And look at some of the words here. I wonder if that's readable for you. I hope so. It looks pretty big on the screen. So I opened this line, but I didn't, do this. I want to take the idea from Hebb that neurons that fire together wire together. And I want to add a sentence. I thought I'd added it right here, but I see I haven't. So I'll edit that. And it will say, and, not Donald Hebb, but Bob Doyle is saying, neurons that were wired together in the past will fire together in the future. Okay? So Hebb, neurons that fired together in the past, wired together, and I want to say those that were wired together in Eric Kandel's childhood brain back in 1938 will fire together in the future. And we know he can recall that. I can recall the scene in the library and who was in the room there in the moment of learning about Kennedy's assassination. I ask you to think back to some really important things and see if you don't have the ability to reproduce. Of course, everything you do whenever you try to recall something, you are attempting to bring it back to your mind, you say, or back to the tip of your tongue, or beyond the tip of the tongue, and goes out and you can say something you've been trying to think about. I would like to build an informational model of how that actually transpires, how it actually comes about, that we can bring back something. We need what I call a reproducer. Oh, and I do see I have that sentence in here. I just didn't recognize it. I'll come back to this one. So neurons that were wired together in the past will fire together in the future. This extension of Hebb's idea is the basis for our experience recorder and reproducer. I call it the ERR. And if you're on my looking on my website, on Information Philosopher, you'll find this blue is a link to the knowledge area. Let me just see if I've got my knowledge area right here. I'll just switch screens for a moment to the ATEM. You see across the top, problems, knowledge, value, free will. The knowledge drop-down menu. Fourth item down is the experience recorder and reproducer. So I recommend that you go there if you want to know more about a lot more than I'm going to be able to fit into my lecture today. But I could stop here for just a moment and point out that these are Ramon y Cajal's drawings made at the end of the 19th century. The neocortex consists primarily of 6 horizontal layers. You can see the different looks, density, and different shaped cells. There are cells here that look like little triangles or pyramids, and others that look like raindrops, and they all get classified. We know a great deal about this today. But what I want to come to is taking the idea of wired together in the past over and say we can go to will fire together in the future. Now, why would they fire together in the future? How would they fire together in the future? What would bring that about, okay? You can just say, well, you try to think about something, you try to bring it back, but what is the actual connectivity, what is the actual signaling or firing in the brain got to do with this? And my model for an experience recorder and reproducer is very simple. Let's say some event, maybe a traumatic event, a very important event. I could imagine, I once in a lecture talk about a young lamb who has this yellow and black striped thing show up and kills and devours its parent, his mother. And one might imagine that in subsequent experiences, the sight of yellow and black stripes might bring back something to mind, okay? And how would that work? Let's say that the visual sensation, the visual cortex in the back of the brain, there are many areas devoted to sensory sensations coming in, like the hearing with the ears and the smell in the nose, but the visual is a separate part of the brain. Into that section comes yellow and black stripes. Now, when the little lamb had this horrible event connected, in my argument, recorded in connection with yellow and black, anything else at that time, the smell, the sound of a roar or something, all of those multiple, 5 different senses are all recorded in different areas of the areas of the brain, of the cortex. And they are associated with one another in ways that are still very puzzling. There are clearly connections between all of these areas. And the most important one, which isn't a sensation that comes into my model for an experience recorder, is the hippocampus and the amygdala, the areas that are connected with our emotions and our feelings. They are not exactly sensations, but they are critical to understanding how it is we can experience something and turn it into learning, which then will be useful when we have a future experience that is in any way similar to the one we had earlier. Learning for me is a succession of experiences that are recorded and then brought back on occasion by the reappearance of something similar. Clearly knowing how things are connected to one another between ideas and words all requires this ability to have new things coming into us associated with older things that we already have and allow us to build up our knowledge, which in our mind is just a large amount of information with a lot of connections. So let's come back to that little lamb. The yellow and black comes in the visual cortex. Now, obviously it comes through the eyes, but it lands way in the back because the connectivity from our eyes crosses over, so left eye, it's hard for me watching myself on a screen to figure out that this is my left eye. The left eye crosses over in the brain and connects to the back of the right hemisphere. A little technical issue, but that yellow and black comes in, and let's say now what Hebb has told us that the pattern of yellow and black has somehow been encoded inside the brain, inside the visual cortex, and it is connected to a lot of other areas, but when it comes in and it fires those for the later time, imagine that all the neurons that were wired together in that early expression, the early experience, that traumatic experience, they all start firing again, including the emotions, okay? So now we have a situation that it's if you are reliving secondarily after the fact, your brain is firing all the neurons which, as a complex set, are reminding you, literally reminding you, making you experience again, reproducing that experience. That's the full picture of my experience recorder and reproducer. The first experience recording is based on Hebb's idea that once the neurons are used, they get wired together. So that means at some early time, the other things, the emotions, the important one, the yellow and black, the emotions, maybe something in our memory of sounds, maybe something in our memory of smells, all gets wired together. So later on, and I don't know if you've ever had this experience, any one of the sensations could set off memories of the other. For example, there are certain smells that can really bring me back. Experiences at the dinner table when I was a teenager, for example. A few lectures ago, we reminded ourselves of the remembrance of things past in which Marcel Proust went to meet an old friend of the family and remembered his mother, and but it was all very vague. It was all pretty gray in his ability to recall this town he hadn't been to for years and years, when suddenly I think the mother or someone offered him a plate of madeleine, these little cookies, little cakes. And this woman in his past had always dipped it in a little tea, dipped the madeleine cookie into the tea, and he did this many years later in our recounting of things past. And when he had the taste of the melting sort of wet cookie and the smell mixture, taste mixture of the madeleine sweet cookie and the tea, suddenly a whole set of visions came back to him of what it was when he was as a young person at this same table or having this same experience. So that to me is a rather literary and powerful sort of image of my experience recorder, and more importantly, a reproducer. A reproducer then, as I see it, gives us a model of memory. And a model of memory is one on which we can build a whole theory of how it is we acquire knowledge. So learning it could be based on a model of mind, a model of a mind, where the mind is basically recording experiences, and we are then recalling them later. Now, some interesting questions arise. For example, is the memory there? How long is it there? And I think Kandel's book tries to make some arguments about that. See if I can really find them. That's one page on Hebb. Because the question arises of how long these last. No, I don't really find it. Oh, I guess it was in the original Hebb book. He said something about, what did he say in his footnote? See page 229 for a further discussion and an elaboration of the assumption made concerning the nature of memory. So maybe we'll take a little bit of a look at that for just a moment and come back to page 6. So I've yellowed this up, and I guess I can go in a little tighter. And what we have here is that for this problem being considered, a solution may be found by assumption two, that an unused connection decays. Or better yet, if we can assume that a very frequently and long used connection becomes permanent. And that was a strong idea for him to say. He thought perhaps it was permanent, because I think we know there are people who can absolutely recall almost every detail, so-called photographic memory. So much so that one needs to be careful that you're not being tricked, by one of these people who claim to see other worlds or contact other people and fool you by tricks, by magic tricks. There are people who can be given a page, selected page, presumably at random, or maybe a wholly new prepared one, and shown to this person who read it. They read it through like this. Maybe they just look at it, and then they put it aside, and they can tell you everything that's on the page. Now, given that any of us can do that, let's assume for a moment we'll take that experience as something established in psychology, and we then assume that those connections that are made may be lasting forever, and the reason that we can't recall everything is we're not that good at recalling things. It's not that they're not in there, but that they are hard to recall. And I have a couple of things to contribute in this area by arguing that things are stored physically in the mind, and they need to be recalled, need to be activated, so the whole system fires again, right? Since it's been wired together. And that has to do with the physics background of what's going on in the brain. There are those who think that maybe everything we know is stored at these synapses, which have been wired together, strengthened, and they contain all of our information. There are others who think that there isn't enough information in all the synapses, even though it's millions of cells, tens of millions of cells, I believe, connected each to another 10,000. Now that is an enormous number, and it's something I hope to think about more as I go forward, whether is that enough to carry everything we know, everything we think we recognize, the whole operation of the mind or the brain. Is that enough in the form, enough data, as we call it, enough bits or bytes of storage? Today we talk about our computers having a terabyte. Seems like we have at least a terabyte up here. But is it enough? And let others argue. I went to a conference a few years ago in Milan where Stu Hameroff worked with Roger Penrose. These are people who have web pages on my site describing their work. Roger Penrose, the great cosmologist, relativity physicist, and Stewart is a former anesthesiologist who's a sort of expert about what happens to the brain when it's anesthetized, and certain parts of the brain or in the cells are chemically altered. And so he's looked at those parts of the cells, which are extremely tiny parts, right down to what's called the cytoskeleton, the structural sections inside a cell that hold the cell up. And of course, the neuron is the one that interests him, I believe. These are microtubules that we will talk again. A couple of days ago, we talked about the molecular machines in our bodies. And I'd like to explore more of them, and we'll get back to microtubules, which are extremely tiny compared to the synapse, the cell as a whole. And Stewart believes that our memory is stored down at a much lower level in the cell. Both how it's stored and how it's reproduced or replayed back remain totally unclear. Whereas the Hebb model of neurons having been wired together because they fired together during some experience, that's pretty clear in my model of how an experience could then be reproduced or played back. It would be sort of like a videotape recorder or a digital computer that's recording things. It would be set off by firing the same cells, and they would then give us, our body, the experience with the feelings. So this would also solve a problem in philosophy of mind called what is the status of the qualia, the qualities of things like our feelings and our particular sensations. What is the qualia of red? The argument goes that whereas we have feelings, David Chalmers could say it's not clear that we can establish that even other humans have the same mental experience with the feelings. On the other hand, it looks like they do. When we stick them, they jump and so forth. But aside from that, he argues maybe others could be robots acting perfectly just like human beings, but absent feelings. So in any case, my approach to this whole notion of qualia is I have a way to store all of those feelings along with our other sensations. Perceptions alone was a big problem in philosophy, and whether we get to the things themselves, we've discussed that, because our perceptions are limited to things that might be hallucinatory or mistaken in some way. And Kant and others, the empiricists we just mentioned, Hume and Locke, were worried about whether we could contact the things themselves. So there's this complex set of problems in philosophy. We can probably make some progress on them, and I hope to do that on pages we will look at again in the future. Maybe you'll look at my site sometime on your own. But I think we now can say we have recognized the work of Hebb, and I wanted to show you one more thing, about his work before we go on. Let's read down a bit more on this page. Today's thinkers who worry about this qualia issue, Dennett is a really big one. The originators of these problems are back in Willard Van Quine at Harvard and Donald Davidson, who worried a great deal about this subject. And today, Dan came along in a time when computers got smarter and smarter. We have artificially intelligent machines, and that's David Chalmers' concern that artificially intelligent machines may become robots and play games with us, take care of us, clean the floors, prepare our food and so forth. Will they be, therefore, can we think of them as beings with a mind? And he would say, yes, but they won't have feelings. They won't have these qualia. And that is a problem for anyone who thinks that the mind, that man is a machine, our body is a machine of some kind, and I'm going to show that it is, I can show, made up of a gazillion tiny molecular level machines. That doesn't make us a machine, but we are a big assembly of a huge number of machines which are phenomenal at what they do. They take care of themselves when they die, sweep themselves away, create new ones at a phenomenal rate, as we've discussed. But we are not, I would like to say, a machine. At least this type of machine we are is more like a biological machine or a living machine, in that it has mechanisms, spinning rotors and phenomenal things that look like jet engines, definitely look like machines, but they're all built out of living things. Every little part of it is a cell. We're all made out of cells and so forth, including the tens of billions or trillions almost of parasites living in our so-called biome, bacterial cells, many more of those than our own human cells. So we are made up of living things. They act like machines. But what's happened in most of analytical philosophy and artificial intelligence in the last few years has been to argue that the brain is a computer, that man is a machine and the brain is a computer. I'm going to say, no, we are a kind of machine, but not a mechanical, material machine that was built by humans. The machines that we think of as machines, like automobiles and airplanes, those are built by humans. The machines that we are, the machines that make up us, build themselves. They assemble themselves. No work on our part. It's all them doing making everything happen. So I think we need to say we are not any ordinary type of machine. And the brain is definitely not a computer, not a digital computer. I've programmed digital computers. I've designed and built little computers which play certain games or do certain functions, and it's been an important part of my life to entrepreneur in the area of little intelligent things that could play games. And I know what the programming is. I went out of my way to insert a little randomness into games that I designed to make them more like an opponent with unpredictable behaviors in the game. That was 1977, and it was 1974 I started doing that. And there are questions about whether computers are totally deterministic machines. And people like Dennett and other philosophers who think we are machines and that computers are machines and that they always absolutely are determined to do whatever they do. It's often said a computer will only do what you ask it to do. If it's making a mistake, it's because you put a mistake into the program. So a computer is a machine that we build, and it's properly called a machine. But this brain of ours is not a computer. It's way beyond the performance capabilities, and especially the extraordinary abilities to recognize patterns and connections with other patterns and draw associations between things. The empiricist philosophers, again coming back to Hume, and Hartley, they had an associationist theory of mind, that the mind was all about its ability to associate ideas and abstract ideas from things in the world. So they would see lots of balls and they'd abstract the idea of the ball, and it would come from this associationist activity. I think those of you who've maybe read a little bit about this and these associationist ideas, you know, we always probe people by saying, think of this, what else does it make you think of? That's the way the brain works. You can see my experience recorder and reproducer is very close to this associationist picture of what goes on in the mind as it associates one idea with another idea, one experience with another experience, because that's what the brain is built to do. It's built to give us back quickly any past experiences that we have that might be useful in our current situation. You can see how a mind model that says at bottom it's just an experience recorder, and the way it works is that whenever you're doing anything new, if the new thing you do has something similar to something you experienced before, it should play back, give you access to the old experience. That makes you an experienced person. It's the one who has knowledge. When we say you have experience, it's there for you to be recalled when you need it in order to help with our current decision or choice of our next action, which I argue is a consequence of my model for the mind of a two-stage model. And I see we're running out of time. I want to remind you that I've developed this new way of looking at my lectures, and I don't know if I actually have that right here somewhere. Here's Information Philosopher. I'd like you to, there's a link to YouTube, but I wanted instead to go to Information Philosopher and right here and see if I can get you my new lecture format. I hope you'll give me some of your criticisms. Maybe you'll go to one of these. See, I'm talking over and not showing you what I'm doing. Here's my new lectures page, and it has the ability to go to any one of these lectures. I'm going to point out that I hope you might go to one of these links at the top and do what's called follow me on my blog or on Twitter, on Facebook, or on YouTube. And when I leave you in just a few minutes, I'm going to go and get the little poster illustration for this lecture on Donald Hebb, put it right here, and today's date, you'll be able to find it, and so on, day after day. We'll turn to metaphysics tomorrow. Okay, well, I think we're running out of time. I appreciate your being with me today, and I hope you like to join me again on other lectures in the near future.